morning, everybody. I've come a long way to talk to all of you, so I hope you're all awake. I can promise you refreshments, coffee, and other goodies, sugar, shortly. So bear with me for 10 minutes, and we'll get you to your refreshments. I won't stand between you and the goodies for too long. I think it was said earlier today that data is the oil for the new economy, which is so true. And that's been said a few years ago. So just like oil, you cannot just use it the moment you pump it out of the ground. You need to fractional distillation is required before you can make meaning out of it. So there is a lot of data, but you got to find information. That's what the digital economy is all about. Because every action you take these days, there is a corresponding action that is digitally recorded. A swipe, or a Yelp, or a tweet, or anything you do, there is a digital footprint from which you need to find information. That's what this whole thing is about. And because of all of this, there's a huge shift in the type and size of data that we are talking about. So far, most of this kind of data science summit conversation has always stopped at the analytical portion of the data. We don't talk enough about the operational side of it. That's where the data first comes in. How do you harness that? What is that data? Let's understand that a little bit more. It's more than just analytical, it's operational. Where does it begin? Where does it all start? It's basically in these applications, web, mobile, and IoT applications. That's where the data is generated. That's what's coming at us fast and furious. On top of it, you need to understand that the structure has completely changed. What was built by databases in the past is no longer the kind of data we are seeing. The speed at which the data comes at us is also tremendous. We all know that. And the size, the sheer volume of data that you have to manage and out of which you have to find information has changed. So the infrastructure that has been there to manage all this data is old and rickety. You need to find a new infrastructure that's going to help you manage all this data deluge. And structure is a very important component here. And everybody just stops talking about structure as though it is just some blogs and tweets. It's not that. The whole idea of unstructured data is that the schema can evolve. If you had a user profile and it had only 3 elements to it, let's say name, age, and address, tomorrow if a new handle comes in like a Facebook or a tweet or a bleat or whatever is going to come, you need to be prepared to see how the schema can be evolved without taking the database down, because the business agility demands that you actually move at the speed of the business and not let your data infrastructure get in the way. So that's a very critical component. So there is a response that is required to this generational shift of what this big data is. What is that? So we at Couchbase have built a platform which can handle all the needs of your IoT, mobile, and web applications. Without this, there is no conversation, because these are all sort of technologies are folding one on top of the other. So you need to have a platform that can address the needs of all these constituencies. So you can build an IoT application, you can build a mobile application, or you can build a connected application in one platform. Why is that critical, if you ask? Is that the big data is going to be so huge, you cannot move it. Logic has to come to data. Data cannot go to logic. Most of the time these days in this analytic world is spent in moving data between an operational system where it originally gathered or originated into an analytical system. That's a sheer waste of compute, storage, and network. So let's talk about the patterns. IoT application, how is it? Let's take this whole platform from the very edge, the IoT. There are sensors and actuators. Actually, the whole problem with this IoT stuff is that there are a lot more sensors than actuators. You cannot do much with just sensing. Yes, you can tell something which a human can interact later on, but if you had more actuators, actually this revolution will go far. That's what will happen there next. Once those sensors and actuators spit out the data, you need to have, at the very edge, some place where you can store this data and you can act on that data. You should be able to act as close to where the event has happened. If you're going to pump all this data all the way to the cloud and then analyze and then bring it back, again, waste of all the resources, most importantly, time. So you need, at the very edge, in the gateway devices, a database where you can gather all this data, because these sensors can put out millions of data. The real information is when a state changes or lack of information, not all of that information. So that's one paradigm of how to build the data. Here, the real differentiator is that sync service, which can seamlessly bring the data from the edge to the cloud. That's what we have built here, where you can take the data from the edge, bring it all the way to the cloud, only the meaningful data, not all of it, so you don't have a data deluge where you don't need to have one. The second paradigm here could be the same IoT, but wearable, where a human and a device interact. The kind of thing you can produce is very, very powerful. So you can build such an application here, and again, the sync gateway comes into play here. Now, the same paradigm can be extended to build a straightforward mobile applications where a human interaction. The common theme here is that you have a database where the data is available locally. All the mobile apps still, only the application logic is running in the device. The data is still sitting behind the firewall someplace. So you'll see all these rotating circles while the data is getting fetched. We have to move away from that paradigm. We build such applications. Ryanair built an application using this where they reduced the total amount of time that it takes to make a reservation from 5 down to 2, because the rest of the stuff was all just waiting for the data to just flow backwards. Now let's go to the core, to the cloud. What you need is a platform that is very easy to develop and that scales, which is the promise of the NoSQL databases, scale-out architectures. We built a query language. It's a very important thing here, is to have a query language, because it has proven the last 40 years of the database industry, many query APIs have come and gone, only SQL stands. Something to be learned from there. The analogy I use here is like an electric car. You don't want to touch all the user interfaces out there, the same steering wheel, the same gears and pedals. What you've really switched out is the internal combustion engine. Everybody has been just playing around with the user interface. That doesn't work really well. You need to go and change only those parts that require changing. SQL is not what is broken just because people said no SQL. The problem is the infrastructure underneath. So we have a query language, which we call NCL, which comes from the non-first normal form algebra, relational algebra, which is built on a relational algebra, and that basically lets you introspect the SQL. If you didn't have a SQL, this is what you would do: instantiate an object, iterate over things, a lot of code. What you can do now with Couchbase is write a simple SQL query. Select star from table, group by. Thing really want to point out here is the join clause that you see there. You can create a relationship between documents, which you couldn't do before this in NoSQL world. On the back end, on the server, it's a shared nothing distributed architecture, which is memory first, most importantly. That's the shift from disk to memory. And we work with all the SSD vendors and NVMe of Intel, where many published benchmarks are there by these vendors. Don't take my word for it. Every vendor wants to come out here and say, mine is the best. Please read up the benchmarks that Intel published and IBM published on us. It beats everything else that's out there. Shared nothing architecture is a great thing. To that, we actually added an in-memory streaming protocol so we can do near real-time stuff. Because of the shared nothing architecture, clean architecture, you also have no single point of failure. To this, we added secondary indexes, and we did it in such a fashion that you could now do workload isolation that allows you to do both scale up and scale out. The lesson we learned out of all this MapReduce stuff is that the scale out kills performance after a certain scale. So you need scale up. Indexes are central, data can be distributed. It's a very profound realization that we came to, and we built it in such a fashion that you can both scale up and scale out. We call this multidimensional scaling. On the server, now going down to the data, here is where the shift is from all the spindle disk to random access like SSDs and NVMEs. So the foundational piece that you used to access or put information in was these B trees, which is old news. We have foundational innovations there as well to allow you to move to these newer technologies where the generational shift has happened to memory, and where we have this ForestDB, which is a B plus trie, which is a tree of trees, and so that reduces the tree height and depth, as well as the width. It's 5 to 10x faster. We also use lockless skipless for our indexes, which gives us concurrency in terms of index updates, which are like 1,000 times faster than what you could do with B trees. So at the end of it, to this whole server, you add geo-replication capability where you can move data quickly across boundaries. This is memory to memory, so it's like within milliseconds. And add great manageability of all this cluster, thousands of nodes. How do you manage it from one enterprise command center, where you can query, deploy, manage, replicate everything? You have a complete server. What you have in front of you is a platform which collapses many things. It's like your iPhone that you carry. It's 40 devices into one. What's the benefit of that? It's cheaper, it's more cost-effective, and it's easier to use. We have collapsed multiple tiers here, multiple applications. It's a cache and a database. It is easy to develop and easy to scale. You don't need to buy 2 different systems for it. It manages structured and semi-structured data. It can scale up and scale out. There are no other system. With the elastic deployment that you have in data centers, this will be very meaningful. It can do offline and always connect the application. We're also working on search, text search, tokenized search, and we are also doing work on analytics. The reason is the data will be in one place. All this logic will come to that data, and you'll be able to develop all your application needs, from the disconnected, occasionally connected, to the really connected and scalable applications in one platform. So that's the innovation we are really after, which is our response to this generational shift of memory getting cheaper, networks getting faster, and data coming at us really fast. That's all I have for all of you. Back to your break with your caffeine and your sugar. Thank you.